Hi, Chuck. Can you hear me?
Yeah, I can hear you, and I just unmuted. Can you hear me?
Oh, good. Yeah, perfect. Excellent. Thank you so much for joining. I know you're tireless, just working hard all day long. How are the kids today?
Oh, I'm not tired. I'm tired.
Yeah.
What?
How are the
Sorry, I didn't
kids
hear the last
today
sentence.
at school?
Talking. Oh, they were pretty good. Yeah, I've got a good group. I like them. It's a block day, so I had my physics students. I didn't even have my computer science students today. I'll have
Oh,
them
okay.
tomorrow.
Mm-hmm. So you've got all AP classes, is that right?
I do this year, yes. I have one
Mm-hmm.
AP physics, and then the rest are AP computer sciences.
Oh, nice. Okay. Good. Well, it looks like we've got a couple people.
Yeah.
But mostly we're recording right now, so we'll just kind of edit out this beginning part when we put it on the website.
Good. All right.
Yeah.
I don't know who Chloe is, but I do know Fred. Like Fred is on. Okay.
Oh, okay. Nice.
Howdy.
Hey,
Hi,
Fred.
Fred. I'm Christine Levy from the Colorado Department of Education.
I'm a volunteer mostly in the schools, and I teach for CU Science Discovery Program.
Oh, wonderful. Great. Which schools do you work in?
In Boulder, Crestview Elementary and Centennial Middle School.
Oh, nice. All right.
Now, Fred, you work with the Atlas program still, don't you?
No, I know Ben Shapiro. I've helped with an instructor who was a PhD student there at the time and taught a couple of classes in using the software that I teach, Agent Cubes.
Right.
But I haven't done that since he left. He got his PhD and split.
Okay. Well.
So there's agent cubes and agent sheets, is that right?
Yes. Well, it's kind of confusing. The company is Agent Sheets. The products are also Agent Sheets and Agent Cubes, and they're both. You can look at them as science modeling tools, but you can make video games with them. Agent Sheets is a two-dimensional version, and Agent Cubes is a three-dimensional version. But the programming paradigms are the same. In fact, almost exactly the same instruction set, if you will.
Uh-huh.
So, in fact, you can convert an Agent Sheets program to Agent Cubes, and so students who've done programming in one can just pick up and go from there.
Oh, great. Okay. Hi, Sean. So I'm going to share my screen now. Let's see. We've got it's not going to let me do it. Okay. Let me just put this away for a second. Okay.
Sean, it's been a while. It's good to see you.
Sorry that I've been a little bit absent. Things are finally starting to calm down though, so I should be able to be a more active participant in a lot more of the computer science things that are going on in the state.
Great. Well, it looks like I'm Ariana Antonio. That's our office manager. So our Zoom license is under her, but I'm actually Christine. So nice to see you, Sean. Thank you for joining us. Appreciate it. What's that? I didn't hear you. Sorry.
Thank you for the invitation.
Got it. Okay. All right. Nice. Okay. So let's see. So I'm going to just share my screen, and you're all welcome to here, let me zoom in a little bit. Okay, so we have a little document link for our meeting. If you would like, it would be great if you could join that document and go ahead and put your email address in there. As we're discussing things, if you have links you want to share or ideas related to anything, feel free to put your name and then, just hop on over to this information area, and you can throw in, different information or links that you think might be useful. So we'll just get started. Basically, we've got an hour set aside to just talk about AP Computer Science and teaching high school computer science. So Chuck Powell is here from Green Mountain High School. He's AP Physics and AP Computer Science teacher, and also the president of the Colorado Computer Science Teachers Association. Long time foundational person in our state. Thank you for all your hard work promoting computer science, Chuck. So I've asked Chuck to talk about AP Computer Science because we've got just over 500 high schools in the state of Colorado, and there's only about 98 right now that are teaching either AP Computer Science principles or AP CSA or some combination.
So Christine, I wonder if you could share somehow that link so we can actually get to it.
The link, can you see it right here on the document? Do you see how it says?
Oh, I see. Let me try to type that in here.
Yeah, there you go.
Okay.
Let me make it bold. Okay.
YB9.
Yeah, YB9EH538.
Okay, got it.
Yeah.
Okay.
Yeah, so so if you're just joining us, if you wouldn't mind muting this is a meeting format, it's not a webinar format, so everybody's able to talk and discuss and share things.
Okay, sorry to interrupt, one more thing, but that's a view-only link.
Oh gosh. All right, let me see if I can change that real quick. I was pretty sure I changed it so it was everybody could.
I mean, I could request edit access, but I think you'll get a lot of people doing that if you don't.
Yeah.
See, right now you've got it as can view. Anyone can view. You need to change that. Below the list. There you go. Up a little bit, says where it says can view.
Oh, gotcha. Okay.
There you go.
Anyone can edit. Thank you so much. Thank you. Awesome.
And now people need to reload and then they can get it. Okay.
Yeah. Thank you for pointing that out. All right. So, so because AP Computer Science is kind of a like, it's a measure of some sort, of how we're doing in the state in terms of offering computer science in all the districts. I've asked Chuck to talk a little bit about that. And then also Sean was, who teaches in Colorado Springs, is that right? I think, yeah. He's got a lot of experience teaching high school in a gamified format, and he was the Colorado High School Teacher of the Year last year. So, so we'll get input from Chuck and Sean, and then anybody else that wants to chime in. At the end, I'm gonna stop this by 8. But at the end, you know, as we're getting closer, if we have time, if everybody's kind of run out of things to say and we have time for questions, we'll try to do some Q&A around 7:45. Okay. Okay, great. So Chuck, you want to just share a little bit about how you got started teaching AP Computer Science and what you think might be the first steps that a teacher might want to pursue if they want to teach AP Computer Science?
Yeah, well, you know, I've been teaching a mix of science and computer science for a long time. And I know, go way back with Kyle, who's also online with us, I don't know, 20 years ago. And then at my school, the computer science teacher left to go somewhere else, which is sometimes a disaster. And I think we're getting to the point that it's less than it used to be. You know, since there's no computer science license in Colorado, you need to find somebody who comes in as a science or math teacher and then kind of works through making their own doorway to start to teach computer science. And so by the time I did that and picked up from the other teacher, the enrollment was down, and that was just about the time that College Board put out a call for computer science principals. And for me, I thought, if I'm going to rebuild this, I'm going to start with this new course with CS principals. And there's several people online that have some good experience with AP Computer Science. So, you know, I want to try to speak as if I'm the only person with some knowledge out here, but I will say that in some settings, it makes a big deal to have a class that's an AP class. And it affects how many people enroll in your course. It affects who enrolls in your course. And that kind of describes my school a little bit. So having an AP course brings me more students in a different group of students than if I don't label it as an AP course. And so it's worked out well at my school. Now, the other thing is, starting out with computer science principles, it's, for me, a little bit easier approach to get going with it. I think there's some great stuff in computer science A, but it can be a heavy uphill battle for both a teacher and a student to get that expertise in the Java programming language. And with computer science principles, it starts from a different perspective, that let's focus on problem solving and use whatever language works for you in your class to be able to implement that logic and those algorithms and that problem solving skills and create programs that way. And now at my school, when I have students in computer science A, they can focus on that Java language because they've already taken computer science principles and they know at least a little bit about that problem solving before they come in there. So there's a quick background of where I'm at and what my perspective is about AP, and in particular about AP computer science principles.
Thank you. Yeah. So, so what do you think teachers should do if they want to teach AP Computer Science? I mean, would you recommend doing an online course or getting Barron's, you know, AP Computer Science book, actually taking the test themselves? What do you think might be some good steps?
I'm kind of a big advocate of in-person training, even in the online world of computer science. You know, there's a whole lot of options out there. Code.org has workshops. Beauty and Joy of Computing has workshops. Harvard CS4CO has workshops. I think if you're just getting started with it, you want that person-to-person contact. I'm not saying that's the only way to do it, but I still think it's kind of the best way to do it. And that's what I recommend for somebody who wants to get into it. Take some time, clear some time, particularly in the summer if you can as a teacher. Once you get started, I don't think it's as hard to stay in as it is to get started. And I think that, you know, if you want to teach computer science And a lot of people already have the background. Some people are ready to get the background. Sometimes you hear a statement about computer science principles that says something like, you don't need any computer science background to teach this course. And it's an in-depth course. It's not a simple course. And I think it's more like this, that if you want to get started and you're willing to put in the effort, you can start without a whole lot of computer science knowledge, but you can't stay there. You know, you need to be able to move up and increase your skills. So, you know, I don't think it's an anybody can teach course, but I think it's anybody with, you know, the willingness to put in the effort and to move beyond where they are right now can certainly do it.
So what type of programming languages would you recommend that teachers start studying on their own so that they can teach programming effectively?
Yeah. Two of the strongest curricula out there are code.org and Beauty and Joy of Computing. And it's particularly for a teacher getting started, I think you want to work with the languages that are in that curriculum. So code.org has their own app building site, and it uses a version of JavaScript. And it's kind of nice because students can learn it in a block style and then work with it later on in a text style. So, I mean, for somebody who wants to start with code.org, I would say just use that programming language. For somebody who wants to start with Beauty and Joy of Computing, which is a really great curriculum, they use a language called Snap that's been developed out there at Berkeley. And it's a great language too, and it fits in with the curriculum. So I think as a first year teacher, you'd want to just go with whatever language is in whatever curriculum you decide to teach. Now, as people develop the expertise, you know, the more you know as a teacher, the more you decide, well, I'm going to make this choice instead of another choice. And one thing that I have chosen is I like to start my students in Snap because working in a block-based language is an excellent way to sort of almost force an understanding of how a program fits together. And a big part of programming logic is how the pieces of the program fit together. And that's what a block-based language is really good for. I spent some time on that in the beginning of the year, and then I moved to Python because Python is kind of an ubiquitous language. It's a powerful language, but it's a language that is almost intuitive. It doesn't have a lot of the overhead that languages like C++ and C# and Java have. And so it's a little bit easier to learn the semantics, which means the kids can get quicker into some of the logic. So again, I would say whatever your curriculum wants to use, but my favorite two languages, block-based Snap, text-based Python for this class.
So what, in terms of sort of a canned curriculum like Code High School or Adhesive or anything like that, have you worked with any of those more software or LMS-based AP, CS curriculums?
Well, the only two I've worked with so far are code.org and Beauty and Joy of Computing. I've heard good things about Edumentum. It grew out of a project at University of Texas, Austin. And I've heard good things about CS4CO, which comes out of Harvard. And but I haven't worked with them personally. I know that there's a lot of people who have used Code High School in their introductory classes, and Code High School has now rolled out a computer science principles curriculum. And I've heard good things from people who have worked with other Code High School products and are now moving into using it for high school. And I don't even know what programming language that Code High School uses for their CS principles.
And did you say Edmentum or?
Yes,
what did you say?
Edmentum, whatever. But yeah,
okay.
I forget the name of the original project out of University of Texas, Austin, but then they had somebody package it and release it more commercially for them, and that's where Edumentum came from.
Oh, okay. Okay. Do you use textbooks with your students?
No, there are lots of online text materials. And so some people like BJC has its own online materials, co.org has its own online materials. Some people will use one because, depending on your school, sometimes there's a feeling that in an AP class, a student ought to have an actual book to carry back and forth. But, that's not been a demand at my school, and I just like the flexibility to move around and borrow from whichever one I want. I don't really teach the co.org curriculum, but I use a lot of it. They have some great lessons, I think, particularly in understanding the internet and in understanding big data. So I like to do those with my students. So there's pieces there that are great. There's some really strong programming stuff in BJC, Beauty and Joy of Computing. It's tough the way that it's put together to adapt it. So if you want to use that and stay with it, it works out well. If you think, well, I want to go ahead and do some things that I've thought of on my own, the way it's packaged, it's tough to just take what they have and adapt. You can certainly work with Snap and put your own assignments in, but it's hard to work with Snap and the BJC curriculum and go in any other direction. Now, the any other direction for, first year teachers, it's probably not going to be a big deal. But I just think that anybody who's been in there more than a year or two, you learn, you understand, you appreciate, you enjoy, and pretty soon you think, I want to do this instead of this. So, you want a curriculum that eventually has the adaptability for you to make the choices that you think are going to be the best things.
I think if it's okay if I talk for just a second. My name is Tina Granado, and I am the co.org program manager for Colorado. And co.org really promotes all languages, all programs, all curriculums across the board, like very robustly they do that. They don't just promote their curriculum, but I would like to say our applications are still open for a few weeks here, and it does offer a K-12 curriculum pathway, and the AP testing is more than doubled with it having that program out there with a 95% pass rate, and teachers have a 98% recommendation rate for it across the United States, and my teachers in Colorado have a 100% recommendation rate. We're going to be hiring, bringing on 128 schools this year, one of the biggest cohorts in the nation. So, I just want to put a plug for it out there. I'm happy to help with any of the curriculums and guide people, but now is our window and there's a few slots left. So just wanted to get that out there while I had the chance.
Thanks, Tina.
Co.org has been one of the biggest builders of the CS community, and they've really put a lot of effort into that. And I know that, Christine, you said earlier that, what are there, 98 schools in Colorado that offer AP computer science? Was that the number that you had?
Yes.
I'm willing to bet that with co.org's cohorts over the summer, that's going to go up significantly by next year. And I think that's great. And I think it is true that, there's some great curriculum from co.org, but co.org doesn't get clingy and pushy about, we only help the people who want to do our thing. They're out there to help the whole community. So that's one thing I really like about co.org.
Yeah, thank you, Chuck. If people are interested, the workshop is free. It's this summer, the 18th through the 22nd, 5 days, and then 5 free quarterly workshops on Saturdays throughout the year.
Great. Okay.
So Tina, that workshop is it for high school or for K through 12 or K through 8 or how?
The workshop is for middle school, so middle school through high school. So the Discoveries program in co.org and the Principals program in co.org. So we have actually so many people. We're using our MindSpark facility as well as another facility because we had such an interest this year. So it depending on whether you're in high school or middle school will depend on which building you're in. But yeah, and then the quarterly workshops will be held at MindSpark Learning, but I have so many people on the Western Slope that we have a building over there that we'll be running those out of. So the Western Slope people will have to come here for the summer workshop, but then they can stay closer to home for the quarterly workshops. And we're training up as many elementary school teachers as we can get across the nation, thousands if I can get them. So we already have most of the school districts booked up for those, and And just also to let you guys know, we have a huge grant from the Gill Foundation that if you're part of a computer science pathway K-12, you're eligible for a robotics kit that's worth about $1,000 plus free PD for a whole day. And if we do a great job, Gill has promised to give us that again next year. So for your friends that are out there in middle and elementary schools, just this week alone, I've recruited 50 schools to be part of the 150. And we already have those workshops scheduled. So help spread the word.
Well, I'll second that motion. Bobby Bastian, who Chuck knows, is a teacher in Adams 12, and she's a code.org instructor, and I've helped her in a number of her workshops, and I'm just totally impressed. That's at the elementary school level. It's an amazing curriculum, and the way it's taught really makes teachers who have zero exposure before feel comfortable with then leading that kind of discussion in their classroom. So, yeah. I haven't seen the curricula for middle and high school, but if it's anything like the elementary school curriculum, it's extremely well done.
Oh, well, thank you. I appreciate that. She is one of our facilitators for elementary as well as high school. She's amazing. And we were able to train 4 other facilitators in Colorado, so we are ready to cover the state with those facilitators.
That's great. That's great.
Excellent. Thank you. Well, I have a few more questions for Chuck. I wondered if you could maybe just share some of your advice, maybe some of the things that you've learned over the years teaching AP Computer Science and anything that you do to help kids get ready for the exams.
Well, yeah. So, what's great about the computer science principles curriculum, both the framework from the College Board and all of the players that have their own curriculum out there, is there's a lot of student choice in there. So there's a lot of place where there are projects where the students use their knowledge and make their own choices about which way they want to go and what program they want to make and what kinds of features they want to put in that program. And I think that you certainly want to make sure that they cover the basics of what's in the programming language and what makes up programming logic, but as much as possible, you have the option to just let them follow their interest and get excited by that, and that works for just about every student. Their interests are different, but almost every interest can go into some high-level computing that they really have to think out some careful logic for. So I think that voice and choice, letting them in that programming language make their own decision about what the program is going to be about and how they're going to say it as much as possible is a real big strength there. So I think that's great. The other thing about computer science principles is it's got this awareness that computing exists in a context, and that context in our world includes things like the internet and big data. And so students need some awareness of that. And I already mentioned the lessons that code.org has on those, but other curriculum have their own lessons and just things you can do as projects in class, just making them understand the basics of how the internet works so that they can think about that when they're writing their programs. The basics of what big data is, how it's presented, what you can do with it, how they can analyze it to use that in their program. So those other pieces besides just the creating programs are important. They can add a lot to the class, but if you want to add a lot, you have to spend a little bit of time on it. You need some activities on it. You need some review on it. So, as you go through the year, I don't leave my review to the end of the year. I'm every couple of weeks bringing us back to something we've done in the past, particularly those things that they're not doing in an ongoing way in their program, but they need to understand the big data and the internet. So lots of review. And that's what I would say. The performance tasks are there, they're built in. Use those for all the strength they have. The students are going to do their own research project for the Explore performance task. They're going to do their own program for the Create performance task. So you don't have to remember to do that. That's a requirement, but prep your kids for that. Let them know how important it is that they express themselves and do a good job on that, and that creativity is an important component, just like the other aspects of computing. Okay.
Great. Thank you for those wonderful words of advice. So on the subject of voice and choice, maybe we'll turn to Sean. And Sean, you want to share with us a little bit about your approach to teaching high school computer science and any advice that you have for new teachers and existing teachers?
Yeah. We had sound issues before. Are they fixed now? You can hear me?
I
Yes,
can
no?
hear you.
Okay.
Thanks.
All right. Yeah, so I actually wasn't a math or science teacher. I was an English and literature language arts teacher. And I got my master's in integrating tech in the classroom, which is all about like Web 2.0 tools and that sort of thing. And there was an opportunity to go down and to take over a position teaching kids about video game design. And so there was a part of me that was like, I'll never have to grade essays again. This is going to be great. I can play video games and it's going to be fantastic. And so I transferred over. It's like the hardest job that I've ever had, but it's also been a lot of fun. But my evolution has been very different, I think, than what someone coming in with a computer science background would have had. So kids and I co-developed a fully equipped and functional video game design studio. And so my approach is a little bit different than what you would see in maybe an AP computer science class, whether you're talking about computer science or you're talking about principles, because we're actually trying to do the entire video game design and development process. And computer science has a huge role in that, but it's not the only role. So, so that's important in terms of context for the kinds of things that I'm about to tell you about. When kids come in, they get the opportunity to go through tutorials and to kind of find their niche. Do they want to be artists? Do they want to be programmers? Everybody has to do at least a little bit of both so that they can be flexible on teams and will be able to talk to each other and understand what their asks actually are to other people that are going to be working on their teams. But we oftentimes take a team-based approach instead of an individual approach, because if we didn't, we would never get to the point where we had final products. And when we first started, we were using a program called Game Maker, which has drag and drop programming, and then you can get it to scripting. And we did that for a couple of years because that's what they were doing at University of Colorado at Colorado Springs. And so we started with that, but it didn't take my kids very long before they were like, I actually want to make 3D games, and I want to make the kinds of things that I see on my console or on my PC. And so we started scaling up, and we got like 5 computers that would run Unity. Unity has C# as the main language that we use. And I had a couple of kids that wanted to do some stuff with Java, so we started off with Greenfoot, and then we moved into doing some stuff with Eclipse in terms of Java programming. Those are the 2 main languages that we play with now for the most part. And part of the reason that we went that way is because we got into doing development for the Oculus Rift, and we got into doing development for the Meta development kit, and we got into doing development for the Microsoft HoloLens. And Unity has, you know, libraries of code that you can go in and that you can use in order to create experiences for that hardware. And so my approach now is I try to run my classroom kind of like a game design studio would run, where I'm the CEO and executive producer of the experiences that the kids are coming up with, but kids get the opportunity to pick games and experiences that they would like to make for the hardware that they would like to develop for. And I put them into teams. We have team leads, we have design leads, we have design leads for like the artistic side of things, and then we have programming leads. And so my teams run anywhere from 3 to up to 10, depending on the complexity of the project. But usually I try to keep them in teams of about 5. And we just try to figure stuff out. There isn't a real set curriculum that we go through once we get into doing the actual like big projects, because there aren't tutorials that are out there that you can just follow when you're trying to develop stuff for the HoloLens, because there aren't a whole lot of tutorials that are, you know, out there, especially not ones that are written for high school kids. So we do a lot of research and a lot of just trying to figure out how to make the hardware work the way that we want to, which is the same kind of process that developers are going through with the kinds of hardware that we use.
Wow. So how many video games are you working on? How many does your studio? What are you working on now?
Yeah, what are we working on now? So I've got one team of kids that is working on trying to create a virtual reality escape room for the Oculus Rift. And the context that they've kind of set their escape room in is it was originally you play as an international art thief, and you have to figure out how to navigate through some of the pieces that are on the inside of the museum. And so they're coming up with their own puzzles that you have to solve. But one of the constraints that I put on my kids when they start working on projects is that they have to figure out how they're going to make whatever experiences they're trying to create educational for other people. And so we've modified that so that now you have to use your knowledge of art history, and they're coming up with information to actually teach people in the game information about art history so that you can find counterfeit pieces that are on the inside of the museum and replace them with the actual artifacts. And we are starting to try and download some of the 3D assets that the Smithsonian Institution has been creating. If you don't know, the Smithsonian has been putting some of their money and resources into creating laser scans to do high quality 3D modeling and mapping of different artifacts, and they're looking for use cases to kind of justify why it's important to keep doing that. And so we're actually going to make a bunch of the artwork that we have got in that escape room artwork that is based on the Smithsonian's collections, both 3D and 2D art. So that's one. The kids have gotten to the point where they've figured out how to make, the Oculus Rift work with their game environment. They figured out how to make the touch controllers do the functionality that they would like for the touch controllers to do for it. If you don't know what the touch controllers are, they're the handheld controllers that you can use for the Oculus Rift. And they have it set right now where you can iterate through different tools the way that you would in an actual, in an actual game that you would get from people. And you have to use those tools to solve different problems. And so that's one. We're working on a game to teach people about light and the physics of light for the Microsoft HoloLens. The HoloLens lets you see and interact with holograms in 3D space, and it does mapping of the environment that you're in. So it'll figure out where the surfaces, like the walls and the ceilings and the floors and the tables, are. And so what the kids are creating right now is a game to teach people about light where a laser emitter will get stuck to a random place on the ceiling, and an exit point will get put on a random place in your room. And your job is to use virtual mirrors to bounce virtual light around the real objects that are in your space. And the kids have laser emitters. They've started working on the spotlight version so that we can put prisms into the space. And that way you can actually refine the wavelengths of light, and we can teach people about light like that. So that's another one. We recently made a virtual reality recreation of a lithograph showing one of the Salem witch trial. It's a fantasized version of what it was, because the lithograph was made in the 1800s. But my students were actually kind of contracted by a group of students in history classes in the school to create a virtual recreation of the lithograph. And so they put in their a one-to-one recreation of the different objects that you see in the scene for the lithograph. And when you look around on the inside of the room, you have the opportunity to hover over where the judge would have sat, and it'll bring up a judge's testimony or the judge's questioning of people that were on trial. And it does the same thing for the witnesses and the original arrest warrants, and those documents were downloaded from a university site. So that's another one that we've been working on. My kids are trying to make an old school arcade cabinet. So the goal with that one is they're actually making a cocktail arcade cabinet. If you remember those, they used to have Pac-Man, and they used to have it in the cocktail lounges. And,
Oh, yeah.
yeah. So my kids are engineering and making the actual physical construction of the table. But they're having to learn about things like RGB lighting and how do controllers work for, getting keyboard inputs into a computer. But then in addition to that, they're also trying to make games that we can take in. We're hoping to install the table that they're creating in the library, and then they're hoping to make a stand-up cabinet as well. So we just got the pieces for that. So that's another one. I've got kids that are working on other random things. So there are a couple of them that aren't quite as educational, that are just a little bit more fun. So kids have made a game where you have to control a hockey puck and go around and pick up pickups, and you can only pick up certain pickups. You're playing against somebody else who's picking up different ones and stuff. Because I had a couple of kids that were really into ice hockey, and then I have a group of kids that were making a gaming experience where you like play as cockroaches, and it's like cockroach tag or something. I don't know. So we have like fun projects like that too, but the majority of the projects that we're trying to take on are these ones that are for the little bit more advanced hardware. We're also developing for the Meta 2, and that one is another holographic headset, but that one does hand tracking, so you can actually like reach out and grab and touch holograms. And so one of the projects that I've got a kid working on is a project to show the change in energy from potential to kinetic using a pendulum. And so you would have the ability to reach out and grab a virtual pendulum and lift it up. And then as the pendulum was moving, it would show a graph in a heads-up display that would show you how the energy was actually transferring. So there's that one. I have one where a kid is talking about trying to make one where when you look at your hands, it would create a simulation of the way that bacteria would spread across your hand. So we've got some like that too. But my environment is very different than most people's environments, right? Like I also have kids that are doing sound recording because they're making their own sound effects and, you know, the background music for the games. And then we also have a motion capture system. And so I've got a group of kids that are working on trying to create a virtual assistant that can be repurposed to go into any of our games. And so we're doing that. I've got a group of kids that are working on a football game where we're using the motion capture to capture all of the animations that we would need so that we could run through different animations the way that you would in like Madden or any of the games that are on the market like that.
Busy place, that classroom.
So Sean,
Yeah.
what school do you teach at?
I teach at William J. Palmer High School in Colorado Springs.
Are there other computer science classes at William J. Palmer?
No, I got the market, which in some ways is good and in some ways is really bad. So occasionally I teach a Java programming class that's a full year, and that one is very much more closely aligned to the kinds of things that most people on this call are probably interested in doing. That one is tied to an IB computer science course. And we used to run the IB computer science course, and I was responsible for implementing that. But in the IB course is set for like a 2-year span. And we've had scheduling issues, so we haven't been able to ever give it 2 years. So I had to get kids from who had never touched programming and had never even really like considered programming at all. I had to get them between August and in January to the point where they could independently identify a project worth doing, something that was in their scope, identify an authentic client that they were going to work with, go through a software development process with the client in order to plan out how you would address a client's need, and go through the development of that, make a video, write a response that was like 2,000 or 3,000 words, and then go through with the client at the end whether or not the program that they created actually met the client's, you know, if it was up to snuff and if it met their expectations, and if not, plan out how they would address that. So with an hour a day, like that's a lot of stuff to try and get kids scaled up for between August and January. And then in addition to that project that's worth like 35% of their IB grade, you also have 2 computer science exams that are all about, you know, how does the hardware work, and, you know, how do you do networking, and what are the essential components of the networking system, and things like that. So it was a huge ask, and I was never able to compact that class down into a 1-hour time slot. So until I can kind of reboot the class, we've sort of put that one on hold.
I have 3 questions for you. One,
Yeah.
have you ever put in for the Colorado Succeeds $15,000 grant? Because I think you'd have a great chance of winning. So
No.
I'm going to throw that out there and have you look that up, because like I am super impressed by what you have done. Second of all, do you ever allow other teachers from other high schools to come and observe with their students, to observe your class or be part of that? Have you done that?
Yeah, so I actually haven't done a whole lot with having other high school teachers come. What I tried to do was to actually uh, try and create partnerships and mentorships between what the kids were doing in my program and what they're doing in elementary and middle schools in my district. Totally open to having people come in and talk with us though. And if it sounds like everything is great, let me just clarify a couple of things. I get a lot of kids who come in and they're like, you know what? I love video games. I love to play video games. This was the same response that I had when I was like, I'm going to go teach about video game design, right? And then you get in and you realize that it's actually really, really hard to go from initial idea all the way to the development of the game. And so I've got a lot of kids who come in and I tell them right from the get-go, like, this is going to be really hard. And it's going to be hard for a whole bunch of reasons. One of them is that you're just not experienced with computer science or modeling or whatever. Like there's that part of it. But it's also really hard because you're going to have to do a lot of independent study. It's going to be a lot of you having to work with other people. You're going to have to like really seriously learn how to think about things in ways that you probably haven't before. All the rest of your classes actually matter when you come into mine. And so sometimes kids don't believe me. So they get in and then they realize like this is really hard. And I'm still working out the best way to support kids when sometimes we get into projects that are way hard. So an example of that is, I know that you had three things, so I'll let you ask your last one in just a second. But here's an example of the kind of thing that I try to use as a real world learning opportunity for the kids. When we got the HoloLens, we thought, oh, you know what would be a cool opportunity is for us to make an experience where when you go out into our courtyard, we have all these memorials that are out in our courtyard because our school is pretty old. Um, and and so we had thought that we were going to be able to make it where when you walked out into the courtyard, you would be able to look at the memorials and the kind of like monuments that we've got that are out in our courtyard, and we would be able to have it bring up information that would tell you about the history of our school and why those memorials were placed. And so we worked on that. We worked on it for like 2.5, 3 months. And we had all these great plans for what that was going to look like, only to walk out into the courtyard one day with the actual headset. You would have thought that we would have done this, but we didn't. 2 months in, we walk out into the courtyard and we finally have some things at the point where we can start testing. We have some memorials that are for students that we've lost. And so we wanted to make sure that we were trying to balance out like, this is going to be a cool way to memorialize them with making sure that we had, parent permission to do this and all of that. We turn on the thing, go out into the courtyard, we look at some of the memorial trees, and it brings up this pane of information, and we're like, sweet, like this is actually starting to work. So then we walk across the courtyard, and what we didn't bank on was the fact that the headset would forget where it was at in the space. And because it didn't have continuous mapping and because there were some parameters that we didn't know about that were limitations on the hardware, we walked halfway across the courtyard only to turn around and see that one of our, thank goodness it wasn't an actual picture of a kid, but one of our like placeholder pictures for a kid had actually like wandered out into traffic, right? And that's not the kind of experience that you want to release to people. There were things that we literally couldn't solve because of the hardware. So we worked for 2.5 months only to find out that our entire project idea was pretty flawed from the beginning. And we had to put the brakes on the project. Now, in a lot of schools, especially if you're trying to follow something like an AP curriculum where you have a test that is completely aligned with content that you're teaching, that working on a project for 2 months only to find out that you actually did things wrong, especially with the amount of time that it took for us to discuss it to begin with, is something that a lot of schools aren't going to have the freedom probably to do, but we have. So we end up with things like that too, right? So I have kids that come in that don't have any idea what they're getting into, kids that come in and love that, kids that come in and kind of struggle with it. The ones that I have the hardest time with in terms of getting them to flip the way that they think and really invest in the process are the kids that come from AP and IB classes. Because they come in and they say, how do I get an A? Right? Like, what does an A look like? And when I say it looks like solving really good problems and working with other people to figure out solutions to things that we don't know how to solve right now, that makes them very, very uncomfortable for the most part. And like an example again, when the kids from the history class came in to kind of like hire my kids, I asked them, so what do my kids get out of this? Because they're basically working for you, right? So what's the benefit for them? And one of my team leads was standing next to me while this conversation was going on. These girls from this history class were like, well, can't you give them extra credit? And I looked at Alex, and Alex said, we don't really work for grades in here. We work to solve really cool problems. And like, so that doesn't really do anything for me. And the girls didn't know what to do next. Like, there wasn't a next step for them because they're so used to having external rewards that for them, considering a class where you weren't working for an A was something that was kind of hard to fathom. But for a lot of kids that I get into my classroom, that's the same thing. So it takes a lot of training to get them to the point where they kind of view the world through that lens. So just so that you know, it's not like all sunshine and roses and everything is great and all of our projects are fantastic. But I'm always open to having people come in and just hang out with us, and you can see what's going on. And there will be times where when you come in, kids will be on their phones and they'll be just talking to each other, and sometimes they're just listening to music. But about half the time, that's because those kids have gone home and actually done like 6 hours worth of work on a project over the last 2 or 3 days, and they finally need some time to kind of take a break. Or what happens too is that kids will get like super stuck on something for a couple of days, and they just need a little bit of time to relax and walk away from the problem so they can come back and actually attack it the right way. But yeah, you're totally welcome to come in.
So, speaking of non-traditional students, what do you have in the way of success in attracting girls and, say, students of color?
Yeah, so the title game design on classes steers girls away. So I'm actually looking at renaming my classes because I have girls who actually do want to come in and they want to make apps and they want to make software, and they actually do oftentimes want to make things that are kind of game-ish, especially when they find out that they can make a game that can actually impact people in a positive way. But just having game design in the title steers girls away.
Yeah,
So that's actually in my plan is to rewrite my course titles and a few of my course descriptions to make it a little bit less focused on the traditional idea of what games are, because I'm pretty sure that these girls think that they're going to come into a classroom that has, boys that will only talk about Fortnite and have Cheetos, stains all over them and stuff. So I'm trying to get that sort of fixed. When I was offering IB computer science, I actually had more girls that were in the class. And when I offered Java programming, I had more girls that were in the class than I have ever in my game design classes. So there's that. In terms of minority representation, I actually have been ramping up in terms of minority representation in the game design classes. Oftentimes, because they're not scared by the course title, right? I think that sometimes when you say AP, there are a whole group of kids that think, well, that class isn't for me then. But when you say game design, they don't think that. And so it's this tricky balance to figure out, how do I create course titles that are actually all welcoming?
Oh, thanks. I teach the game design class using this other software, and for CU Science Discovery Program, it's for elementary and middle school kids. And when we advertise it as just game design, if I get 2 or 3 girls out of 18, that's doing really well. When we advertise it as game design for girls only, it's oversubscribed.
Yep.
So,
and I think that that's something that we would run into too, right? Is it's all about in how you market it. One of the things that I found though is that when I say game design, if I say game design and girls opt in, oftentimes they opt in so that they can do the drawing and the coloring and the 3D modeling, and less so that they can come in and do like hardcore computer science, because they don't view that as like part of the designing process. And so again, like those are like terms that we're trying to work out. I did, however, run at one point a mentorship-based technology club that was girls only, and I got my district to change a stupid board policy that hadn't been looked at since the 80s so that I could have high school girls and middle school girls in the same club. And when I marketed it as a girls only technology club that was an after school experience, I had girls that opted in. when I asked kids, do you want to have a girls only technology class in the school? They straight told me no.
Here's
That's
one thing.
interesting.
I know I say this all the time, but I'm going to say it one more time. A lot of you know this, but some of you don't. I mean, I worked in the software industry for 25 years. I ran my own company and several big software companies. I was always the only woman. And having run those companies, one of the things you said today totally resonated with me, of making jobs in your class, of different things that you'd sign up to be responsible for. And I think one of the disservices that we're doing in computer science right now is focusing just on programming, because of all the people I managed. I always say, and I've said this a million times, Christine's probably tired of hearing it, but if you have 100 people to do a software job, 20 of those are programming, and the other 80 are jobs that we are not we're not building our students for. It's why there's these jobs out there. And I'm
Right.
always out there saying, like, you know, I run code.org for Colorado, but coding is not my favorite thing. And I had an amazing career and made a ton of money not coding. I mean, you have to know how to code, but it isn't all there is. And so I think I love that you have jobs in your class for all of the different parts that make a software product work. And I'd love to see more focus on that. My last two questions for you, I didn't get in, is
Sorry.
a great resource for so many people in Colorado. Chuck's on the phone right now, but I know there's some opportunities we talked about last night in CSTA. If you would be willing to come down for one of those, I think teachers would love to be able to hear you and learn from you and have you be part of one of the sessions. So we have a meeting coming up next week, but we're talking about what we want next year. And I would love to bring up some of the work you've done and see if people would be interested. If you'd be willing, we could, you know, I mean, honestly, I would help pay for your travel from MindSpark Learning just to get you there, to be able to have people listen to you. And then also in EDCO is the Colorado Tech Conference. I think it's a little late for applications now, but I will hit you up next year when they're recruiting, because so many people could learn from you. I hate to volunteer you.
I'm actually going to be
Are
presenting.
you? Okay, great.
Yeah.
Great.
And it is.
Okay, great. I will help promote for my network of people to get into your classes, and hopefully I'll be there as well. But those are the other two things I just wanted to put out there with you. Kudos to the work that you've done.
Thanks.
Well, maybe Chuck can answer this, but in one of the past meetings, there was I don't know if it was Skype or Zoom or Google Hangout connection. So if you can't make the meeting, Sean, maybe you could connect that way. Chuck, if you're available, can you respond to that?
Okay, sorry, I was pushing the wrong button to unmute myself. Yeah, we always have a Google Hangout, but the other thing is this time there's actually going to be a session in Colorado Springs for our April 12th meeting. And Mark, I can't remember his last name right now, is coordinating to get a room at Colorado College. And he's tried to share that through a couple of the Colorado Springs district. And I'm going to send out a reminder for our meeting tomorrow. And I know there's some people like you, Sean, who are on our mailing list. And I will point out that for those of you that want to attend that meeting, that you can go, I think 5:30 on April 12th up to Colorado College Science Building. And he's got a room there, and we'll be sharing by video between School of Mines and Colorado College.
Mark's
Cool.
last name is Holthouse, and he's the Teal representative for Colorado.
Great.
Yeah,
Does
there's an
anybody?
open invitation for anybody who wants to ever come down. You're more than welcome to come down and just hang out and stuff. Even if it's after school, if you'd like to just come down and see the space and play with my toys, I have really cool toys.
Wonderful. Thank you. Does anybody else have questions for Chuck or Sean? Okay.
I'm going to answer a question that nobody's asked, but that I
Mhm.
get asked in other places that might be of relevance. I get a lot of people who say, with the sheer number of projects that you have going on at any given point, how does it get managed? And so one of the things that I spend a lot of my time on is actually not teaching kids about computer science, because there's tutorials and curriculum and there's all sorts of stuff out on the internet for that. What kids don't know about is project management. And so I spend a lot of my time teaching kids about project management and getting them into the habit of using Kanban boards, both digital and in whiteboards in class, in order to be able to identify tasks that they want to take on and to be able to do progress tracking and monitoring and share that out with people. And this year we got into using Office 365 Teams so that kids had a warehouse where they could store their information, so that they could go ahead and post. There's a couple of planning resources that are in that allow you to post where you're at in terms of status updates and stuff. So if you're not using a Kanban board, but you would like to get into doing projects with kids, and maybe you I don't know where you're at with your projects and stuff, but I found it a really useful tool.
That's wonderful to hear. That's one of the biggest jobs out there right now, and there's really not a lot of that going on in the high schools and even in colleges very well. So it's really great to hear that you're offering that.
Yeah, and I've got some resources too that I'd be happy to share with people. I went to an ISTE presentation at one point, and this guy got up and he was like, here's 50 tools that'll help you in your classroom. And then at the end, he was like, and here's this one. It's like super old, but you can't really it's super easy. So I guess that I'll just show it to you. And it was just an online Post-it note program. And so I actually still use that. I went to ISTE in 2010, but we're using Linoit as our space to do online digital Kanban boards, because it gives you the ability to have anonymous posting, but you can also do, groups and stuff. But it allows you to post videos, to post images, in addition to the sticky notes, as well as documents. And so kids can post their projects and everybody has access to it. And so
that's great. I presented ISTE too on a little bit of some of this stuff, and FETC, and one of my favorite tools just for trying is Trello. Actually, a lot of my friends in the software industry were using Trello, and I actually use it to manage all the work that I do. So it's a good free tool, and I used it even in elementary school to teach kids how to do project-based and manage their projects and get started with that skill set. So that's great to hear. Well, I will tweet about you and tell all my followers to attend your sessions at ISTE and at IDCO. I appreciate your time.
Yeah, no pressure.
Thanks. Just one last thing. So, we're always trying to get kids ready for work and college. And so I'm just wondering if both Chuck and Sean, if you could maybe just talk a little bit about how you help kids document their skills that they're attaining and cultivating, and then how do you, obviously AP Computer Science is worth a couple credits in college, but also kids are learning skills in the AP Computer Science class. So if you could just maybe talk a few moments about how you're helping kids document their journey and their learning, that would be great.
Yeah, I don't know if this is exactly answering that, but it's close. So in my school, we have a volunteer that arranges career shadows for students. And me, with my computer science, I use about 60% of what our school does in there. So I take over that quite a bit. I send my students out to software and technology places a whole lot. So I would say not every one of my students does this, but I would say about 50% of them in all my computer science classes spend at least one day each year going out and spending time on the job with somebody who works in computer science. And as they prep for this, they have to make a resume that documents their skills, and they have to do some research on the company they're going to visit. And so they really have to put a lot of thought into it. And even though AP is heavy on the academics, it helps them to get that picture of what you're talking about, Tina, that there are different things that are out there when they're actually on the job. And they'll come back and they'll tell me about all the aspects they saw of it, that the people are not just sitting there writing programs, that they spend a lot of time in meetings specking out programs, and a lot of time analyzing problems, a lot of times looking at customer specs. So that's where most of my students get most of that experience.
We don't have a thriving game development industry down here in the Springs. And so getting them out to see people that are doing the kind of work that they're doing has been a challenge, one that we're trying to work on. one of the things that I've tried to do in moving to the project management approach is to give kids opportunities throughout projects to document what the entire evolution of a project was like, so that when they get to the end, they actually have a body of work that shows evolution of a project over time, that shows snapshots of what their role was. I try to have them do some writing throughout to explain, how they decided that certain parts of the project were things that they wanted to take on. And then I have them think about what are the transversal skills, right? So what are the things that actually cross different parts of the process? Because if you're just a coder and that's all that you do, you're not actually well prepared to go out into the world. You have to be able to explain what your process was like. You need to explain what your thought process was like. You need to be able to do code commenting. You need to be a good teammate. So I try to get them to think about what are the skill sets that they have that actually go beyond. But I'm still working on formalizing the process. I have one kid who's kind of piloting something for me where he's taken a bunch of the work that he's done and he's creating a website so that he has his own personal brand that is attached to the work that he's done across all of his different parts of the various projects that he's been a part of. The kids who get to the end of my classes and decide that they want to continue on, oftentimes they get to the point where they're with me for 3 or 4 hours a day. And so those are the kids that historically I've done a lot more of that work with, but I'm trying to work it back now so that we have better evidence for everybody. And but that's still in the pipeline. One of the things that we are looking at going toward is more of a certification-based approach instead of trying to articulate to colleges, because one of the struggles that I'm having is that my kids are doing things that are related to what they're doing in the industry, but that doesn't necessarily translate to a good articulation agreement with colleges, because colleges oftentimes are teaching programming or they're teaching modeling, but they're not teaching game design. And so we're thinking about going the certification route just so that we have the ability for kids to opt in and actually end up with skills that are marketable, regardless of which one of those pathways they decide to go down.
Yeah. Great. Yeah, portfolios and personal web pages, those are great places that kids can use, over time to document their skills and their skill sets, other concepts that they're learning and their achievements. So it's 8:02. Thanks, everybody. I appreciate your time. Any last burning questions or comments?
I just
All
want to say
right.
thanks for coordinating this.
Oh, of course.
Yes,
Yeah.
thank you.
Thank
Yeah, we're
you.
going to have 2 of these a month. So the next one is in 2 weeks, and that's in the middle of the day on a Wednesday at the noon hour, and that's on cybersecurity. So,
So, Kristen, how are you sending out notifications for this?
Basically just through my listserv, and then I've got it on the CDE website.
Okay.
But if you have suggestions about how we can get the word out, that would be great.
Yeah, I'll help you now that I know and I'm getting them from you. I will forward them to the Technology Leadership Forum. That's most of the representatives at the school districts level, especially in the metro area and up north mostly. So I'll help get the word out, and also to the code.org, and then Chuck has it for CSTA. So I'll think,
Great. Yeah, and this is recorded. It'll go on the website. So if someone missed it and they want to listen in, they definitely can. All right. Thank you very much, everyone. Have a nice evening.
Good night.
Okay. Bye.
Thank you for the push on those. Oh, shoot. She got off. Never mind. Have a great night.